and Dr. Fahad Al-Khodairi, second speaker, who is a corporate fellow at SABIC in Riyadh. We'll be delivering his talk on the carbon fiber downstream manufacturing opportunities in Saudi Arabia.
Okay, thank you very much. Assalamu alaikum, good morning, good afternoon, ladies and gentlemen. I would like actually to take this opportunity to thank Professor Gilles and his team for organizing this workshop as the first workshop or event on composite materials from Saudi Arabia. The creation of the society, of the Saudi Society for Composite Materials is a great move for KSA, and we appreciate KAUST and Professor Gilles for taking the lead here. My presentation consists of three parts: SABIC overview, SABIC, I will also cover SABIC Thermoplastic Composite platform that we're working on today. And I will conclude or close with composite opportunities in Saudi Arabia, particularly those related to carbon fiber. But let me take this opportunity and give you some brief about SABIC. SABIC was established 50 years ago in 1976 by a royal decree creating a Saudi Basic Industry Corporation, SABIC, to shift the country from its almost total dependence on crude oil export to a broader industrial base for further value creation. Today, SABIC has 32,000 present all over the world and have 32,000 employees are working in manufacturing, sales and marketing, supply chain, and other supporting functions, including technology and innovation, engineering, shared services, human resources, and others, legal and other departments. SABIC Corporation Excellence, Capacity and Portfolio Diversification put it the third largest chemical company in the world, and the second valuable brand in chemical industry, based on the latest by 2021 by Forbes, by Brand Finance. It is the second at $4 billion after BASF. The SABIC growth journey was ambitious, to be honest with you. It started since 1976. Series of events, including joint ventures and acquisitions, helped SABIC to be one of the fastest growing and reputable chemical companies in the world. The last thing took place is in 2020, Aramco acquired 70% stake in SABIC, which will lead to further growth and synergies. We do have a lot of experience from these JVs and acquisitions, and also our own developments and technologies. We are also, we have developed a number of technologies in chemicals and polymers and specialty as well. But the key events here are the JV with ExxonMobil, Shell, and Mitsubishi, also with SK for the elastomers, and the latest one in 2018, it was acquiring 25% of Clariant. But in terms of polymers, we went through really good investments with DSM when we bought particularly the polyolefins part of DSM, and then followed by Huntsman from UK, and finally in 2007, GE Plastics. On this slide, I'm showing the SABIC portfolio. It may, to you, not common to some of you that these products come together, but this is the fact. This is where we are today. SABIC portfolio range from petrochemicals to specialty products to agri-nutrients and steel. The chemical and polymers are our core business. This includes glycol, olefins, methanol, MTBE, polyethylene, polypropylene, polycarbonate, elastomers, and engineering, thermoplastics, many stuff for small products like PVC, polystyrene, polyester, and others. And because of this, SABIC today is ranked #1 in glycol and in MTBE, which is added to the gasoline to improve the octane. And also #2 in methanol, and #3 in polyethylene, and #5 in polypropylene. All composites-related activities are done under the petrochemical and specialty business units. When it comes to technology and innovation, where I work for, SABIC have today 19 technology centers. This includes also customer support centers around the world, mainly in 4 continents. 4 of them actually located in KSA, 2 in Riyadh, which is one is SABIC, which is responsible to develop applications and products. And the other one is in the industrial area in Riyadh, specialize in chemical and polymer processes and catalysis. And this one will move to Jubail in 2 years' time, close to some of the manufacturing facilities. The third center is in Jubail. They have also analytical and supporting methods and other some. And while we are moving there, they start supporting polymers and other chemicals products. And the fourth center, we have it here at KAUST. We have our corporate research department specialized in chemicals and polymers and also advanced materials. This slide is just to highlight to you and show you that our materials, the degree of diversity and applications that SABIC Specialty Portfolio serve using our Ultim and Extreme and Norel and Lexane and Lexan and compounds. There are a number of certified materials that are used today in commercial aircrafts by Airbus and Boeing. As you can see here, applications such as roof panels, seats, tray table arms, coffee maker chases, footrests, window frames, galley equipments, armrests, and structural supports, and many others. This is really good. I mean, to go to such applications in civil aviation, it's a long way. It needs certification and need to prove our materials that pass all tests. Now I'll move to the second part of my presentation, which is our effort and activities on thermoplastic composites platform. I'm selecting only 2 products, for this. But before I go to that, as you know, most of fiber reinforced plastic, which we call FRP in automotive and aerospace and renewable energy structures, have been based on thermoset matrix fiber reinforced composites over the last few decades due to their high performance. However, these materials have complex repair procedures and generate significant amount of scrap due to recyclability difficulties and environmental challenges. While thermoplastic composite materials have shown excellent properties and features to meet the current demand for such applications and to provide great solutions to solve mission difficulties facing thermoset-based composites, this is a true opportunity for polymers in the past years, and particularly those composites based on thermoplastics. So thermoplastics composites manufacturing and joining processes has encouraged its application by reducing the production cost and allowing efficient assembly of simple parts to produce large and complex structures. The market opportunity and benefits are clearly seen in many end-use applications, and consumer electronics and automotive are only examples. You can see the thickness in a few years' time, it went significantly low, and as well as the weight of mobile phones. The same thing applied to the automotive. Lightweighting is more than ever nowadays, and more to come actually. This is the concept I promised to present to you and share with you. I will share this solution and highlight our effort in thermoplastic composite. One of the earlier thermoplastic composites developed by Sabic was Stamax. Many of you maybe heard this product, and which was particularly developed to serve automotive industry. Stamax is made by impregnating long fiber glass with additives and PP, producing cable wiring. Then we cool it and chop it and package it. This Stamax is produced in 4 grades actually. One is a 20%, which in composite we call it volume fraction, but here we call it loading. 20% all the way to 60%. The 60% use also with it hybrid, homopolymer polypropylene. And the more you go this direction, the thinner of polypropylene you find. So the good thing that our Stamax key differentiator is built on surface and design support by which we greatly reduce weight and simply cost. Our average Stamax actually application weighing 3 kg replacing 7 kg of steel. Can you imagine this? I mean, this is a huge lightweight reduction in automotive when it comes to many parts in the car or in the automobile. So these examples of these applications are shown in this slide. And as you can see here, the front end, which weighs 3 kg, this is one example. IB carrier, also another example, which weighs about 4 kg, and door module also 4 kg, tailgate as well as 6 kg. I'll come back to this tailgate when I talk about the next example. The second example, which is UD tapes or unidirectional tapes. This is again use unidirectional glass fibers impregnating polypropylene, but unlike Stamax, it is made in the form of tape to provide high performance properties and serve broader segments, including consumer electronics, rail, automotives, sporting goods. The market size from these segments is estimated to generate $300 million per year or per annum, and expected to grow due to the ability of unidirectional tapes to deliver fast cycle time, but processing via injection over molding, joining via welding. We don't need to use adhesives here. The use of existing injection molding, the availability of these assets will help, and recyclability are also additional advantages. These tapes are cut into the desired shape and put in laminates in different axes, and then used in different, as I mentioned, different applications. This is the RTV or reinforced thermoplastic pipe as an example to replace the thermosetting-based pipes today used. Now moving to the next slide, just to continue on the UD direction. This is a good example comparison between the thermoplastic-based composites and the commodity injection molded, using injection molding, and our development. This is the UD tapes and the UD hybrid, and as a function of cost and as well as performance. So you can clearly see the difference between the three. Of course, we cannot replace all the applications that thermosetting-based composites today is serving, but there is a good opportunity here to capture some of these applications because of these improvements that we made. Time is reduced to 1/3 processing, and also the cost is reduced significantly. So I'm sure when we move this to next level, we will be capturing some of these applications and also solving some of the environmental challenges and saving a lot of, making value actually, more value creation for downstream industry and for converters and OEMs. Just to show you more, we were encouraged to go further actually and demonstrate this technology. We launched a collaboration with George Kaufman, with company multi-system tooling, and Kraus Maffei for their automated injection molding, and also University of Delaware to carry out the mechanical, quasi-static, and dynamic testing. And let me share with you this video clip, which will show you fully automated process that was completed in less than a minute, in about 45 seconds, completing the whole particle. Let me just try, I hope it works. It's a very big size, large size video. Here is the gripping the laminates, then take it to the oven to heat it up, and then grip it back and place it between the molds. Over mold it with the Stamax, with the PP, and then having the final finished product in something like 43 seconds. Yep. Yeah, okay. Now I'll move to my last part. I hope I'm doing good with time. So covering the carbon fiber opportunities in Saudi Arabia, it's not moving. Yeah, okay. But before highlighting these opportunities, I would like to share with you the global view of carbon fiber consumption in main market segments. The reason I'm focusing on this because it is related to my next slides. The industrial segments, as you see here in 2017, it represents 55 of the total consumption of carbon fiber. It is expected that in 2025, this will grow by to 60%, which is about the average annual growth rate is about 11%. And this is mainly attributed to the automotive and wind energy subsegments. They will grow by 19 and 18% respectively. So that's why we see a huge opportunity to invest more in these two segments and the two subsegments. Looking to the value chain of carbon fiber and local content ambition in KSA, you will see that the marked areas, these ones, are the ambition of our local market. These are the wind blades, automotive structures, cable and high performance pipes, and the pressure vessels. This goes to many applications, including wind energy, automotive, as well as oil and gas, aviation, civil aviation, and others. The most important thing here that localizing intermediate materials are essential for attracting manufacturing and of finished products. Without this, nothing will happen here. So this is why we are trying to promote the local content and encourage the intermediate materials. Some of these materials will be provided by local suppliers like Sabic, for example, can provide some of these materials, but we rely on others to bring pre-breaks, tapes, textiles, as well as thermoset molding compounds and others. So what are the drivers in KSA for carbon fibers? From the 2030 vision, we have really challenging targets, very ambitious, and we already started here doing some of these projects. The renewable energy or wind energy is one of the really good opportunities. The government announced 16 gigawatts of wind power installation by 2030. They already announced the first contract for $500 million to produce 400 megabyte in the Domat El Jandal in the north of KSA, which will feed about 70,000 houses by electricity. This will use carbon fiber blades, and I'll show you later how much quantities we are expecting to use to produce or to make this 16 gigabytes, the 16 gigawatt wind park at different places in Saudi Arabia. The second one is automotive. Localization of automotive is very important for KSA. KSA today is 35 million. The population of 35 million is growing very fast, and the new vehicle sales in KSA is expected to grow to 700K per year in 2025. So the Kingdom initiative to localize vehicle manufacturing is one of the targets of 2030 vision. And in this regard, we are in SABIC very active. Our R&D, or technology and innovation, promoting the use of thermoplastic-based composite, as I described earlier. One of the areas that we see it very important as well is the civil aviation industry. However, we also, our Crown Prince signed a memorandum of understanding with Boeing 2 years ago. We see localization of civil aviation industry structures is vital for us and important. The only challenge we have that this technology, or the high performance or high strength fibers, are export controlled, and we are trying to solve this issue by mitigating all the putting plans on ground to see how can we help the Kingdom in mitigating this challenge. The summary of my presentation, that the polycarbonate based polyacrylonitrile based carbon fiber is a must for the Kingdom. Carbon fiber intermediate products, pre-break, pultrusion, compounding are essential as well for KSA potential industry. Standards and high carbon fiber performance are required to meet the requirement of KSA local market in aviation, auto, oil and gas, construction, wind energy. The renewable energy 2030 vision will substantially increase the carbon fiber demand in KSA. Just to highlight the quantity that we are expecting to use from carbon fiber, the wind turbine generator, which will produce about maybe 5 to 6 megawatts of electricity. Each blade will need about 10 kg of carbon fiber. Each turbine uses 3 blades, and the total is about 30 kg. And if we're having 16 gigawatt, if we have to produce 16 gigawatt of electricity, this means that we will need to add 1.6 every year. That will use about 3,000 up to 3,200 kilograms of carbon fiber, about 3,000, about 3 lines, manufacturing lines of carbon fiber. Over 10 years, this is 32,000. And that is a huge quantity to be utilized here in the Kingdom. And it's good opportunity for investors to come and put these infrastructures and facilities to produce carbon fiber, as well as the downstream for it. The expansion of non-metallic, as my colleague Dr. Jamil mentioned earlier, materials for use in oil and gas, such as reinforced thermoplastic pipes, is another also attractive opportunity. Localizing intermediate materials are essential, as I mentioned, of these finished product. With this, I come to the end of my presentation. Thank you for your listening and paying attention.
Thank you very much, Dr. Khodairi. Very interesting talk about the development of SABIC, about the thermoplastic composite and the carbon fiber market. So we have one question here. I just read out from the Q&A. Is SABIC considering to use the thermoplastic as a core of the optical fiber so that it meets the requirements for the dielectric waveguides? Or do you have plans to consider?
Yeah, good question. You know, we are not in the business of producing glass fibers. We are a resin producer. The glass fiber I mentioned to you, we secured it through resources, external resources. But if we see an opportunity in the future that we can combine our, engineering plastics or resins, commodity polymers, and collaborate with others in future, yes, why not? We are open to any opportunity that will generate value for both partners.
Okay, thank you. And so regarding the production of the front end part of the automotive parts using this thermoplastic composite, so is SABIC also working on the crash analysis, pedestrian safety, and head injury criteria for fabrication of this part?
You mean for the Stamax, right?
Yeah, for the Stamax. Yeah, the second part of your talk.
Yeah. Yes, we do. We have a team who help the downstream. Whenever we make a material or a resin, we provide it in terms of solution. So we provide surface with it. We educate our the converters down to the OEMs on the use and the best processing conditions. This includes safety and hazardous precautions and everything. We always continue working with them and providing directions to them, helping working together. So both process and performance modeling services is provided in collaboration with Ts and OEMs.
Okay, all right. Thank you. So we have another questions. This is from anonymous attendee. So I will just read you the questions. Is SABIC or Aramco is planning to invest in carbon fiber production in KSA? That's basically the short question.
Yeah, this is a good subject to talk about in the kingdom. We are studying whether we go for carbon fiber or not. Nothing on ground yet, but there is a feasibility study to whether it's worth to invest in carbon fiber. We are a private company. We also we will make sure that whenever we move to a new project, it is a profitable project. We understand that the need for the kingdom, this is important, and we are obligated to serve this one. Let me assume that if we come to break even with this one, we may go, but nothing, no plans on ground yet. No, nothing. But in the past, I mean, a few years back, we did work with Montefebri and we licensed the technology.
Dr. Khodairi, you are on mute. Please unmute.
Okay. I don't know how this went. How far did you miss the answer?
Just a few seconds.
Okay. I mean, there is currently no decision to invest in carbon fiber, but we are studying. I mean, there is a feasibility study to see how we go.
Right. So we have 2 minutes left. So I will just ask one question. You mentioned in the conclusion that for the carbon fiber productions. So what is the motivation of selecting this polyacrylonitrile for processing carbon fiber? Do you have any specific reason for using
acrylic monomers is 95 or even more in the industry. They use acrylic monomers to make carbon fiber. Because we are a chemical producer, this is for us. We have the knowledge about chemical industry, and we can also look into this in the future. We don't produce it today, but if anyone wants to have acrylonitrile, we can help them securing this from outside source, or even studying, investing in this as well. The remaining part of carbon fiber is based on pitch, pitch, which is mainly this one will give us high stiffness. We don't need high stiffness in Kingdom. High stiffness will go to military, and we are not targeting military industries. All what we need for the wind energy applications, automotive, and it's polyacrylic, polyacrylonitrile is enough for us.
Okay. Excellent. Thank you very much.
But these are, as well, and it's important to say, these are proven technologies. The carbon fiber based on acrylic, monomers. This is a proven technology, and it is available for license if it is below the, the export control. I mean, less than what we know, T700 grades. But again, the qualification, is also more easy when it comes to when it is based on polyacrylonitrile.
Okay, so you're targeting the below similar product as a T300, for example.
T300, T400, T700. These are. It's easy to get in Kingdom. Actually, it's not under export control. I believe. Okay. But when it goes to high strength, T800 and above, this is a really challenging thing.
Okay. Thank you very much, Dr. Khodairi, for your talk.
You're welcome. You're welcome.
Thank you.